Alright, so this is where we left off, and I showed you with the graphing calculator. I wasn't trying to rush through anything. But again, as I've mentioned before, graphing the period of a function is basically just saying how often the same exact visual repeats itself. So you can see, at tangent, it repeats every pi radians. Their x-intercepts at pi, and it's going up and to the right, down and to the left, down and to the left. So for tangent and cotangent, if that question shows up, I'm sure it will, repeats every pi radians. So just put that in the back of your mind as you have that. So what that means is, as I get to the next exercise, now you could use a graphing calculator to do this. Matter of fact, I still have it pulled up from where I left. Is I could just hit, second equation would be y equals 3, and as I flip to the other, remember 2 pi is about 6.28. 3.14 times 2, so negative 6.28. So if I go back to the graphing calculator, I just want to see how many times they intersect before I get to 6.28. Okay, so that's too many times over here. But then back on this side as well, as you get through all of your answers, okay, that's too far to the left. So I counted 1, 2, 3, 4 solutions. But this should also make sense that tangent is positive. If you went around the unit circle, well, tangent's positive in the first quadrant. Well, that's negative in the second. It's positive in the third, and negative in the fourth. So one counterclockwise revolution hits, once over here and once over here. But then you also want to go clockwise to count for the negative 2 pi revolution. So it's basically doing 2 revolutions. How many times does tangent hit that? I think it's also important, because I mentioned in the first video, that tangent, from geometry, if I call that theta, is equal to opposite over adjacent, so SOHCAHTOA. That there's no limitation on what tangent can equal, because the opposite could be larger than adjacent, or adjacent could be larger than the opposite if theta is right here. So that's why if I go back to my graph that I drew up here, there's no limitation on what tangent can equal. Tangent can be negative 1,000,000 if I really wanted to, or positive 1,000,000. It'd be a very, very thin triangle, if opposite was 1,000,000 and adjacent was 1, but it is possible. Just to throw that out there, that the range of tangent is negative infinity to infinity. We could not say the same thing about secant or cosecant. There's definitely a limitation to those values. And then just one more problem. At how many values of x on the interval from 0 to pi is tangent equal to cosine? Well, a quick way of checking this is with a graphing calculator, so let's do that first. So I'm just pulling this up. And all I care about is between 0 and pi. Pi's right here in case you're curious. So between 0 and pi, there's 2 times that they cross each other. 2. But if you think about it, as far as the unit circle goes, in the first quadrant, now cosine can only be values between 0 and 1. Remember, cosine is the x-coordinate on the unit circle, so and it's positive. And tangent can be any value between 0 and infinity, but again, it's positive there. So there's one time from 0 to pi over 2 where they're going to cross. And then in the second quadrant, because we care about going all the way to pi, well, tangent's negative, so is cosine. So the values for cosine would be between -1 and 0, and the values between for tangent would be between negative infinity and 0 as well. So they do cross. The only way to get the exact answer, though, on Desmos, there we go, is I would say at this point we're going to just need a calculator to figure out where they would cross each other to get the values. But without a calculator, you could figure out how many times they cross. So at this point, you should be ready for the homework. I only need you to do 6.8, but I've kind of given you a lot of clues in here, and I think I gave you a few answers. And thinking about how the max for the sine function is going to be the minimum for the cosecant function. So that's a good, at least, starting point for you. Please use your calculator. I don't care if you use Desmos or your graphing calculator. And yeah, I did give you a few of these answers, but that's okay. I'm perfectly fine with you as long as you understand. Okay, I did talk about cotangent as well. So I only need to see your last 2 pages of 6.8. I shared with you 6.7 as a refresher, and then your upcoming test actually covers everything from earlier in this, I'll just say semester, because I think it's important that we are continuing to, as we learn new skills, we don't forget about old ones. So I'm not going to change the test around to only be graphs. It's going to be a mix of graphs and everything on the unit circle. So be ready for that.